Hello and welcome to today's class. Today we shall be handling definite and indefinite integrals. The first two videos under integration, we basically looked at how to perform integration given a derivative. And so in this particular video, we are going to go slightly deeper and tackle what we call definite and indefinite integrals. So basically, we have two types of integrals. All right. At any given point, you may be performing either a definite integration or an indefinite integral problem. All right. So what is a definite integral problem? So at a point, let's say, where you are given a problem where you're supposed to integrate, usually this is a sign that we give for an integral problem. So this here is simply an instruction that you should integrate. It's basically like an S sign, all right? So usually if you're given an S sign, and let's say you're given a function f of x, okay? A function basically that is made of x variable. That is what that means, all right? And you're told to differentiate it with respect to x and without any limits. Then we call this what? We call this an indefinite integral. We are going to do a problem under this, then you are going to see what we mean by that. However, if you're given a second scenario, all right? So if you're given a second scenario B, of course, you're given an integral problem. Remember, this simply means that you're supposed to integrate a function f again of x with respect to x, all right? So you're supposed to integrate a function f made of variable x, that is f of x with respect to x, and you're given limits. And you're given limits, let's say, running from a to b, okay? Running from a to b. Okay, this here we call it a definite integral. Why? Because the limits are clearly defined, all right? The limits are clearly defined. And we're also going to handle a problem under definite integrals. Then you will be able to understand what we're talking about. Now, before we go to that, I'd like to maybe make a clarification note and say that usually when you are given a definite integral, a is usually the lower limit, all right? A is usually the lower limit, and B is usually the upper limit. All right, and B is usually the upper limit. All right, so why don't we go ahead and see an example that actually involves, first of all, we're going to begin with an indefinite integral, as that is somewhat familiar with what we've been doing in the previous classes. Then we'll go to definite integral problems. Okay, so for our first example, under indefinite integrals, we are going to solve these two problems. So we're supposed to find the indefinite integral of these functions here. So basically, remember this sign here means integrate. So this here means that we are supposed to integrate x squared plus 1 with respect to x, all right? That is how we read it. Integrate fx squared plus 1 with respect to x. That is what dx means. Dx simply means with respect to, all right, with respect to x. And then the second part, okay, the second part of that question after we solved Roman 1, we'll solve Roman 2. Basically, we are supposed to integrate x cubed plus 4x with respect to what? With respect to x. Now, these are indefinite integrals, meaning that limits are not defined. You can clearly see that we just have the integral sign and that we don't have any limits. And so we're going to differentiate, we're going to integrate them the same way we were integrating the previous problems. So this basically means that for us to basically go ahead and perform our integration for x squared plus 1 with respect to x, we are going to basically have x plus 1, that is going to be x cubed, divide by the power that is we have there as that is 3, of course. Yeah, you remember that we're supposed to add 1 to the power, all right? Then here for 1, of course, we know that x is raised to 0 in 1 here, and so when we add 1 there, it's basically going to be x. All right, the coefficient is 1, so we can assume it. And so basically we're going to have x all over 1, which we can always assume, and we are going to add our constant, which actually is the y-intercept. That is a point when the curve, assuming this is a curve, intersects the y-axis in the Cartesian plane. And so that is going to be the solution to the first problem of this particular example. Then we are then going to basically go and tackle the second part. I want you to note that this is the same thing we've been doing, that the only thing that has changed here basically is maybe the notation, where now we are using the integral sign. All right, so this is an indefinite integral. So we'll do the same for the second example. All right, so for the second example, of course, we are trying to find the integration of x cubed plus 4x with respect to x. Okay, so this basically means that you're going to add 1 to the power of x here, which is 3. So that's going to be x raised to 4 divide by 4. Whatever we have in the index, we shall divide the whole term with. All right, so plus, now of course we have the power of x here is 1, so that's basically going to give us 4x squared divide by 2 plus c. All right, since we don't have any constant, plus c. So that's going to be our constant. But notice that we can simplify this term further, and therefore when we simplify it further, it's basically going to be x raised to 4 all over 4. All right, plus 4 divided by 2 is going to be 2x squared plus c. So that's going to be the solution for the second problem. And you can already see that indefinite integrals are very easy to handle. They're the same problems that we've been handling in the previous example. Why don't we go ahead and handle a problem under under a defined integral? All right, that is an integral with limits. Okay, so for the second and the last example, so we are going to involve basically evaluate problems that involve definite integrals. All right, so I say that definite integrals are integrals that have limits. All right, so you can look at the first problem. We're supposed to evaluate the integration of x cubed minus 5 with respect to x for the limits 0 and 1. Of course, I said that 0 here is the lower limit and 1 there is the upper limit. And so in the second example, we have another problem again where we're supposed to integrate from limits 2 to 3 of 3x cubed minus 4x plus 5 with respect to x. So we are going to solve the first problem, and note this here is a definite integration problem, and so we're going to handle it different from how we've been handling the other problems involving indefinite integrals. And so the integration from limits 0 to 1 of x raised to 4 minus 5 with respect to x will be given by, we will start by opening a bracket. Okay, we'll start by opening the solution to this with a parenthesis, open parenthesis, okay, which you can clearly see I have there. So we are going to add 1 to x raised to, we're going to add 1 to 4, the index of x, okay, in the first term there. So that's basically going to be x raised to 5, and then we're going to divide the whole term by 5, that is x, okay. And then for negative 5, we are going to have it as negative. The value of x in 5 there is 0, so we add 1 to 0, okay. So basically it's going to be 5. When you have 1 to 0, you get x, okay. So basically x raised to 1, of course, and the whole term divide by 1, which we can not, we can neglect and not write. I mean, it's term divide by 1 anyway, so that's going to give us the same term. All right, so after we've done this, we are going to indicate and show the limits of this integration as 0 and 1 on the right hand side. And I also want you to note that what we're doing different here is that we have not included the constant that is c. We didn't include the constant c here, and the reason why is because this particular problem has limits. It's been properly defined that we are dealing with the integration of this function from 0 to 1, and therefore we don't have to include the c constant, okay, the constant which we included under indefinite integrals. All right, so this method is usually used to find the areas under curves, and that is something we'll be looking at in the future classes. But anyways, let us concentrate on this. So how do we go about solving this problem from where we are right now? So for us to solve this problem, basically, we are going to substitute the values of x with the upper limit and then subtract it from whatever we'll get to the lower limit. Now, let me just show you that in writing. So for us to go ahead and solve this, we will take an open bracket. So wherever we have x, we are going to put the upper limit, okay, that is 1. So we are going to have 1 raised to 5, which will be 1, okay. 1, when you raise 1 to 5, will be 1 all over 5, all right, minus, okay, 5 times 1, okay, minus 5 times 1, which will basically be 5, all right, okay. And now that we have everything on the upper limit, we will then subtract by inputting the value of the lower limit in the equation, okay. So we're going to then have minus the same equation here, but now we are going to put in places of x the lower limit, all right. So we're going to then have 0 raised to 5, which is just 0 all over 5, okay, minus 5 times 5, which actually happens to be 0, okay. 5 times 0, I mean 5 times 0, in place of x, we're going to put 0 in the lower limit, okay. So 5 times 0, we're going to basically have 0, so this will be 0 here. And so notice that this here will be negative 4, and let me just confirm that in my calculator. Yes, that will be negative 4 and 4 all over 5. Negative 4 and 4 over 5, okay, for the left hand side. And for the right hand side, we are going to have 0. So all of that minus 0, which basically gives our answer as negative 4 and 4 all over 5. And that is the solution for this particular problem. The solution for this particular problem therefore becomes negative 4 and 4 all over 5. I think that is it. So that is how we solve a problem that actually involves definite integrals, okay, with limits. We don't include the c, and we substitute for the values of x and subtract the lower limits, and then we are able to actually then go ahead and solve for the integral problem that we have in that particular situation. Let us do the last example here and see what we are going to get as our answer. So we are having the integration of 3x squared minus 4x plus 5 with respect to x for the limits 2 to 3. All right, so basically when you integrate this particular problem with we're going to start with having an open bracket. When you integrate this particular problem, notice we are going to have 3x x cubed, okay, 3x cubed divided by 3. And so 3x cubed divided by 3, I'm going to submit it to you that is basically going to be x cubed, okay, that's basically going to be x cubed. So for this particular problem, I want you to confirm, all right, because I don't want to go, don't want to waste time trying to show how we are doing all that, when now I believe that you should already know. So basically that's going to be that for 3x squared, all right. So it's going to be x cubed, and now this here is going to be negative 4x1, negative 4x raised to 1. When you integrate that, is going to be negative 2x squared. Okay, so basically we've added 1 to the power of x here, and that was 2. Then 2 divided by -4 gives you 2. Of course, that is going to be -2x squared. I believe that should make sense. Okay, plus 5x. Okay, since the value of x there is 0, we add 1 to it, and so we end up having 5x. All right, so by now I expect that these should start making sense, and you should be able to solve these particular problems without really thinking very much about it. All right, so then we include the lower limit here and the upper limit right there. Okay, but you see, this problem is not yet solved. Okay, we are going to then have the upper lit minus the lower limit, okay, having been substituted into the function that we have here. So basically that's going to let us just have an open bracket, a parenthesis. So basically that's going to give us x cubed, and for the value of x here we are using 3 in the upper limit, so that's going to be 3 raised to 3, okay, minus 2 into 3 squared, okay, plus 5 into 3, okay. All right, so that is for the upper limit, minus everything in the lower limit, minus, okay. So wherever we have x, we're going to have 2 for this particular equation, so that's going to be 2 cubed, okay, 2 cubed, okay, minus 2 into 2 squared, all right, plus 5 into 2, plus 5 into 2. I'm really sorry you're not able to see that, but that is 5 into 2. All right, so basically I want you to key this into your calculator and tell me what you are getting, and then maybe we proceed from there. Yes, now when you key the left hand side, okay, into your calculator, notice that you are going to get 24. And so for the right hand side, you will get, yes, when you have this in your calculator, that is 2 cubed minus 2 into 2 squared plus 5 into 2, you will get that gives you 10. And so 24 minus 10 basically gives you 14. And therefore 14 becomes the answer for this particular problem. So that is it for definite and indefinite integrals. If you have any question, drop it in the comment section. I'll see you in the next class. Thank you and have a good day.